copies. Will it be copies or not? Because what will be if area has some initial value before parallel section? So let it be area, for example, equals to 10. What will be in this case?
So suppose it's going to be 10. So it's not going to take a copy per se. It's going to take a 0. So suppose the first thread, suppose we want to add 5 to the, suppose area equals to 10, we want to add 5 via using 5 threads. So the first thread is going to have 0 plus 5 is going to be 5. The second one is 0 plus 5, 0 plus 5 is going to add all of it together. And at the end is going to be 10 plus threads 5 multiplied by 5 basically, which is 25.
So basically, it won't be copies.
Yeah, I meant like it's going to be, if it's addition, it's going to be a 0, and then if it's multiplication, it's going to be a 1.
Okay, so you have time to implement the critical section because it is also a part of your task.
Yes, sir.
Okay?
Yes, sir. Thank you.
Hello, Ashish, yes? Ashish. Which task you will represent? Ask task 2, and that's all?
Not every task 2, and I don't know, sir, I also wrote on the message, I showed you task 3 and you also told me that it's good and I have to make graphs. But I don't know, you wrote it in the spreadsheet that I got the wrong answer. I think you, like, I think it was some other person and you wrote my name. I can show you my task.
Okay. So firstly launch it.
How many?
Oh, Ashish can enter. Yes.
Now it's working. With how many? 2?
And let it be 3 processes. But as I remember, there was incorrect result, yes, before?
Yeah.
What was wrong?
Last time what I was doing, like, it was some silly error. I used 2 for loops inside, and like, it was, I just copied 2 for loops, and instead of j I was increasing I. That was some silly.
Okay, so what about your graphs of speed up?
Speed up, because before that it was not working, the remote machine wasn't working, so I didn't do the graphs yet, but I'll do it. I can do it now. And I can show you the task 3.
And about, let's see your program firstly.
Yeah.
Gabriel and Monica, do you hear me? So it seems that the remote machine is working now and you can enter.
I'm unable to, sir. I just tried.
Because Ashish can, and Daniel, have you tried? No? So we'll see. It supports, it works now.
Is my program.
So it works, yes. Thanks. How you, okay, what do you do with the remainder, by the way?
I just send it to the last process. All the remainders, whatever is left, I send it to the last process.
So while can you a little bit turn like this, because find a different scheme. So this is just for one process, yes, exactly.
And then for just for one process, and then if there are more than one, So if rank is equal to size minus 1, then I'm adding all the remainder to the last part.
So I think I was discussed this that this approach is not very effective.
Yeah, you told us to distribute equally among.
Yes.
I tried. There was some. I tried that, but there were some errors, so I reverted back.
Okay.
And the time.
So if rank minus size. So while loop. So why you consider odd and even processes? What for?
Because what we can do is we can separate. Like suppose there are two odd processes, that is 1 and 3. So that can work independently, one at a time. But for 1 and 2 to work, two need the left element from first, and also from the right from the second part. So they can work independently. Like the odd can work independently and the even can work independently. But odd needs even part. It's the left even part, and odd needs the right even part. So it works like that. So that's why we can use this approach.
And what you can say about the time of exchanging time in this case? Will it depend on number of processes or not?
Yeah, of course. I think this approach. No, I think not in this approach. No, not.
Why?
Why? Because when I just remember, we put it in the speeder formula and we somehow get the time to be constant without.
Why the time is constant?
So I forgot. I really don't know. I forgot about that. When I was in a lecture, you told us, but I forgot about that after that. And it was a long time ago. I don't remember.
It doesn't matter. Do you remember or not? You can get the answer logically.
But
you can think.
Because I think because it's constant because every even and every odd are working simultaneously such that the time is constant. It doesn't matter on the number of threads or processes because every process is working simultaneously, and we are not stopping. Like we don't need to wait for some answer, I think. So that's the reason.
Yes, you're right. You have separated your processes on pairs, and each act of exchanging, there is time for just one time to exchange values between pairs. One act and then second, third, and fourth. It will be just 4 acts of by time. In mean of time. It will be just 4 acts of exchanging values.
Yeah.
Okay, what will be further?
Maybe I don't know what will happen if I just remove it.
Yes, because in paper.
I think I should not use NPI. Maybe my program.
And here you collect. Yes, here you collect.
I send all my answer to the rank first rank 0, and then I just print it from rank 0.
Okay, I suppose it's okay with the program. So, I'm expecting graphs from you because graphs of speed up is
I also want to show you task
is important part of your task.
Yeah, I just do that. I want to show you the task
Number 3.
So what was the command to run it?
I don't know, I don't remember. For all of you, the graphs of speed up is very important part of your task. Because when you deal with parallelization, there are 2 goals you have to achieve. One goal is to get correct result. And the second goal is to get correct good speed up, because this is parallelization, parallel program. So when you get correct result but not getting good speed up, so this is a question. Why is it so? That's why I insist on the graphs. You can take not 1 billion points, I suppose, to show me the result. You can use just 1 million. We can get. And what is the correct, I mean, exact answer? Do you know?
I think it's the correct one.
Why is it so? What is the exact?
Exact are calculated as
Have you compared your result with the exact?
Yeah. I think it's the correct one because on the first time when I showed you, like I calculated the result and it was correct. I think it's the correct one.
But maybe today your program give me or give us incorrect answer.
Sir, will I get a bonus point for attendance? Will I get a bonus point for attendance?
Okay, it's correct. Okay.
It's correct?
Yes, it's correct. What about graphs?
Same, sir. I'll just do it now. And I just want to show you the 4th one also.
What do you want to do?
Run task code.
And what about the code?
Oh, you want?
So you did it just using critical section.
Yeah.
And where is critical section? And what it is? What is it?
It means that if we are accessing some global shared variable and we want to do some operation on the shared variable, then we use critical section.
What for?
To make changes to the global variable.
Why? What is the problem?
And what is the problem?
Problem with shared variable when you write?
Because there are many threads using that, and it can change the value in such a way that we can't do our operation correctly, and it can suppose for thread 0, the global shared variable value should be 0, but then our next thread is also working So next thread changes the value instantly, so we can't use the value in the thread 0. So this can be a problem. So we use some semaphore, some wait and some post to just log the like critical section, and we can use it so that single thread can use it.
Can you explain this mechanism in detail with semaphores? How does same-wait function work, and how does same-pause function work, and what semaphore is? What is it? Semaphore.
Semaphore is just a variable to. It's just like a variable so that we know that our one thread is working right now, and we don't need to, and another thread can't use that section. That's just that.
Is this variable private or global?
No, semi-net is global. Like semi is global.
And what else? What about same-wait function?
Same-wait function, when we go inside a same-wait function, it do -1, and like whatever the value of sem is, it do -1, and when we go to semport, it do +1.
And why you construct critical section using these functions and semaphore?
Because suppose the value here is 4, suppose the value here is 4 or something else, it means that simultaneously the number of threads that can use a critical section is 1. I think so.
So you have said that, let's see what will be if the initial value of semaphore equals to 4. No? Am I right or not?
What does this one mean?
When 1?
The initial value of semaphore here is
1.
Okay, and what does this 0 mean?
This is an attribute of semaphore.
Yeah. So what do you mean to say? If the value of 1 is here is
4, for example, what will be?
The output should be that all the 4 threads will be able to use this critical section simultaneously.
And will it be critical section in our terms?
In our case, it won't be critical section because all threads are using this. It will be just like if we remove this and all threads are using it.
Okay, so graphs. What does it mean 4?
It means like inside, because I have 4 processors, so I set the number of threads to be 4. Each processor is using 1 thread. So inside the function, when we use the pragma for parallel, inside part I just print 4 just to check if 4 threads are working.
Can you type SN4 to see idle? So we can see that there are a lot of idle nodes in the cluster. So when you plot the graphs, all people, can you see? Yes, or can you hear me? Because a lot of nodes in the cluster are idle. So to plot graphs, you should use Slurm. You can use Slurm, and in this case, you can use more threads or more processes than 4, because 4 is the maximum threads or processes you can use when you are on the client machine. Okay, and if you want to use more physical cores or physical processors, you have used Slurm script and launch your program through Slurm. okay, via slope. If you didn't plot any graphs, and this concern you.
Should I need to show the program?
So there are no any graphs in this case also.
Oh, yeah, I can show you the first graph. Yeah, I have done the first the graph for the first one. I can show you.
Yes.
Should I show you the code of this?
Of course. And where the how does the OpenMP works?
Like what do you mean? How does OpenMP work? We can
Where is the parallelization or parallel section?
In OpenMP we can specify the program. In which part do we need to run the parallel part? Suppose in this. Suppose in this section I have the pragma directive #pragma-mp parallel reduction. So I'm using the reduction mechanism for the critical section, as we don't need any specific function for that, as we need in the MPI. So we need we have here declared the area that this is a global variable and we are going to use this plus operation. So that's why we used it, and we can define the parallel part. So we are directing the program to use all the processors in this area, So that's how it works. We can define the serial part and the parallel part independently.
Have you implemented the critical section part of your task? Yes, for this, because task 4. Okay, in task 4 you have do critical section and reduction mechanism.
Okay.
And
Okay.
without or.
Okay.
Critical
but
section.
in third it's just one, right?
Huh?
But in task 3 we can only do by it's just our choice to do it by either reduction or critical section.
In task 3, you should use critical section, and if you want, it will be better if you do critical section and the threat exit mechanism.
But in this it is necessary.
Yes, of course. Yes.
Okay. I'll just do it also.
And what is the mechanism of reduction in detail? Because area is a shared variable, and you where is it?
Which variable is shared?
Area.
Yeah, area
is shared, and you can add to this shared variable something.
Yeah.
And without any errors, and you.
Because I have defined in the reduction plus column area.
And what does it mean?
That means that we can add into the area, the variable area, without any problem, because all threads, it's just we can say it's just a reduction mechanism. That's how it works.
And how does it work?
Whatever that operation we define here, that suppose this is plus, then we can add into the area anything, and it won't interfere with other threads.
But how will this variable inside parallel section be shared or no?
Inside this parallel section be shared in the reduction mechanism. You mean to say if every thread will make a copy and then add it in the end? Yes, in the reduction mechanism. Yeah, I think yes. It will make a copy and then add it in the global variable.
Okay, but will it be will these variables be copy of initial shared variable or not? What is the about?
I think it will be.
What will be if area, the initial value of area, be something like 10, for example?
No, it will be 0.
Inside
the parallel part.
And please repeat as a whole your considerations about reduction mechanism.
When we use reduction area, each thread will make a copy of that variable, and it will, in the end, all the thread which will have area will be added into the global variable.
But what about the initial value of these copies?
Yeah, the initial value of these copies will be 0.
Why 0?
Because we are calculating each part independently.
Now, which initial value will be if there is a multiplying, not summarizing, but multiplying operation? Okay, why? When you consider multiplier, the initial value will be 1, and when you deal with summarizing, it will be 0.
I think because if we multiply anything by 0, it will be 0. So I think.
So the initial value inside parallel section, initial value is neutral to this operation. So 0 is neutral to addition, and 1 is neutral to
1 is neutral to multiplication, division.
Multiplication. Okay, so graphs and critical section, yes.
So sir, how much time do we have to complete all the tasks in this class only, or?
Let's consider firstly in this class.
Okay.
Okay, who will be the next one?
I want to ask one more thing, sir. So, will I receive bonus for attendance?
We have to see the complete task or complete table. I mean, I didn't remember.
As I saw, if I attended one more class, I would attend, I think, 12 classes.
12? I suppose, yes, additional one. If 12, because we have 16, I suppose.
Yeah, 16.
16?
Because
if it will be 12, yes, it's more than
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So yes.
12.
And your first task also without graphs, I suppose.
I've done the graph. I'll just maybe show you on like again. I'll show you again.
Okay.
Thank you.
Which tasks? 4?
Yes.
Just 4 and that's all?
Yeah, now just 4. Yeah. Okay.
So first of all, you have to launch it to show the result. And how many threads do you use?
For this one, I have to check because I was making graphs, so I was changing the number of threads. Yes. For this one, 4.
I see.
For the graph, I see some streaks. I did it using slum.
Yes, the graph is rather strange.
Yeah.
Because this task is can be parallelized very well with a good speed up. I mean, what does it mean, good speed up? There is bisection. Bisection, I mean bisection of this angle. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on.
Again?
I mean bisection. Do you see what does it mean bisection? It divides the angle in two equal parts.
Okay.
So
Bisection.
bisection.
I know.
Bisection. And this is the ideal case, the ideal graph of your speed up, when there is no any non-idealities in time of exchange and so on. So this is an ideal case. And the task 3, task 4, and even task 2, when you take a lot of points, these tasks are parallelized very well. I mean very well, I mean the graph of speed up lies very closely to this bisection. So in your case, yes, it doesn't lie. I don't know why is it so.
What are the usual reasons for that?
The reasons. Can you open the script file for Slurm? And how you have changed the number of threads when you launch your program to plot your speed up graph?
Like this, over here.
Just over here.
Yes, yes.
So 4, 5, and so on.
Yes, 4.
Okay.
So on.
Now I see. Now open please on the script file. And you just one node and tasks per node, number of plots per node, and CPUs per task equal to 8. And you never changed this, never changed. So what you ask from the system, you just ask about 8 physical cores. 8 physical cores. If you change the number of threads inside your program, for example 10 or 20, we can see here. Anyway, you will be given just 8 physical cores.
Okay.
And there will be no speed up more than 8.
Okay.
No more than 8 on your graph.
Yeah, somewhere else.
So yes, so this is the maximum will be the maximum speed up, I suppose, because when you launch parallel program, that means all threads, okay, every thread or every process should be launched on one physical core or physical processor. So one thread for one core, one process for one core. If the two processes will be launched on one core, that means they will influence to each other.
Oh, okay.
And you will never get the speed up equals to 2, for example.
So that consumes time.
Yes, it will consume time, and it will be interference between these processes and threads. So it is a case when you change threads inside your program and do not change any numbers here.
Per task.
Yes, per task. CPUs per task. That means you just ask from Slurm, okay, Slurm, can you give me 8 physical cores? Because this cores means number of threads, the maximum number of threads. So how to how to change the number of threads? So you should change just this number, and if you open your program, you should not change this one, OMP set now threads.
should not.
You should not, because by default, the number of your threads inside your program will be equal to number inside your script file by default. So by default, the number of threads is given to you by the system.
Okay, so here
You have to comment. You can comment this line. No, just comment on set num threads.
if I comment, how will I get over here then?
Because when your parallel section starts here, the number of threads will be equal to the number given by system, by operational system, or by, for example, okay, let's say by Slurm. Firstly, when you launched the script file, Slurm knows about how many threads do you want, 8 or 10 or 7, and it doesn't matter. And after that, Slurm gives your program information about how many threads you have asked before. And by default, the number of threads inside your parallel section will be equal to those number, to that number.
Okay.
By default.
That will give good speed.
I don't know, maybe something wrong with your program, or we can see right now. But it seems that there is some speed up. So maybe.
Why is it so strange?
I don't know exactly now, because I do not see which thread correspond to this maximum value. What is it?
Maybe 3.
Maybe 3, maybe 4. We can see. Okay. So I cannot say why is it so. It seems that the maximum correspond to 4 threads maybe, and somehow maybe you have launched this program maybe just on the client machine without Slurm. No. So I don't know actually.
Maybe I'll change it to that way and then show again or no?
Let's firstly see your program.
Okay.
Can you spread the window with your program? It's very small.
How do I increase the font?
I can see. Just a little bit turn the left, like this.
Maybe.
So you have implemented just shared, and
I thought that reduction was not necessary. I mean, just one, I thought.
No, and critical section by you have implemented not okay. It's almost the same atomic operation. By the way, atomic operation is just for one operation. Just for one, and critical section is for a lot of operations inside. So when you use atomic, you just can use just one plus one addition. When you use critical section, you can put into this critical section a lot of addition or multiply or something else, and so on.
Yeah, I saw it in the PDF.
That's why critical section is more general, something like this, and atomic is a particular case.
Yes, I saw. I think I saw it in your PDF presentation.
So my ID, number of threads, and so on. What is the okay, how you use OpenMP to parallelize your program? What is the features of OpenMP?
So
here, yeah.
Yeah, so here I use this so that all my threads run in parallel and perform this segment. And then here I use critical section so that when I calculate, only one thread can complete its task, and then the other thread can enter. To synchronize. So that I don't miss anything.
Yes, you're right. But by the way, What is the problem solved by using critical section? What is the problem with shared variable? Why you should use critical section?
Well, if I don't use this, for example, there are parallel threads working, right? They're together at a time. For example, I get some value over here, calculated some value. I get over here, suppose I have some operation over here. I don't do that operation until then this value gets updated. So this portion might get missed. I mean, the data won't be synchronized properly for that. For example, for solution over here, it won't be synchronized because something will be missed or data can be override. I mean, I can maybe explain with.
Okay, now I understand what you are saying.
Yeah.
Okay. Okay, and how many threads will be inside parallel section?
Just one at a time.
In parallel section?
No, in parallel section, all of them.
All of them?
Yeah.
If you set the number and without setting?
Without setting, just 4, whatever I will have on my, like, default.
Default, yes.
Yeah. So default is 4 maybe.
It's suppose the default number is equals to, it depends on system, on
No, I tried it, so it's 4, I think.
On your laptop, yes, maybe, but on the remote machine, it's 4 on the client. Client node, yes, it's also 4. Okay, so this is the only one task you wanted to show me. So maybe try to replot the graph.
Okay. Yes, I will.
So now you know how to rearrange. Okay.
So you want me to just comment this line?
Yes, comment this line and change.
Make changes over there and then keep on calculating. Right?
Didn't catch. Just comment and compile and run using script.
Okay.
And you should change the number of threads inside script only.
Okay.
And that's all.
I'll try.
Who wants to be next?
Cluster is not connected. So last time I presented the task 3 and you said it was wrong answer. Now I fixed the answer.
Okay. What was wrong?
The answer was a bit wrong when I increased the...
Why? It was wrong.
The difference was, I don't know, when I increased the number of threads it was wrong.
And now?
Now I...
Did you fix?
Yes.
And what did you fix?
Just a second. First it was just NP minus NP minus. Now I just use NP minus 1. I just experimented with this, and it worked.
Okay, let's see. Can you turn a little bit laptop? Like this. How many points now? 1 billion?
I think so. Should I stop it?
No, I suppose. How many threads here?
I just think 1.
Maybe it's reasonable to stop and
How it works.
Works. My solution and analytical solution, and my solution is for just one thread?
Yes.
Okay, let's see what will be if we change the number. Time.
What should I change it to?
Let it be 4. So 4, and in this case the time should be approximately be like which? How do you think? If time for 1 is 37, and time for
4 divided by 4?
And how many? Which
9,
time?
9.
Okay. So if your program is good, the time should be approximately 9. Let's see.
I think I should use Slurm for that, sir. If I want to get, because this I'm running locally.
So, okay, but this is client machine. When you launch like this, that means you launch on a client machine, on the client machine. So, client machine has maximum 4 physical cores for you.
Okay.
So 4 it's okay, and you can see that okay, time is as predicted, as it was predicted. 9, okay. So what about this is a graph speed up, yes, I suppose, and it seems. It seems that you on the client machine, I suppose.
Yes, on the client machine.
Because you can see the this line is almost bisection, and after that
it's crazy after that.
Yes.
This is all I wanted to show you. This is just the answer was wrong last time, so I just fixed it. That's it.
And the graph was from the last class?
Yes.
So, by the way, if you, for example, get a good result, correct result, you can replot the graph, because now cluster. So as bad should I, or should using just the client machine, I can just plot again? No, if you use just client machine, the graph will be the same.
Yeah, so
of course. Let's do one thing. Yes, let's use Slurm script and plot graph till 10. Till 10. And on the same plot, no, on the same graph. So
here, do you want me to draw another line in?
Another line and to compare.
Yeah. Okay.
So it will be a good task and a good comparison.
Yeah. Okay. So
let's open your program once more to see.
Crashed.
No, it's just frozen a little bit, I suppose. Maybe. We can.
You already asked me the question, sir. You said, why would you use SAM? Why would you use SAMPost?
I have asked.
Yes, I answered that.
Okay. And what about p3 join? What does it mean? p3 join. What this function for?
It joins all the threads in the end. Here we create all the threads, and then after that we join all the threads in the end.
Okay. Do you want to show another?
No,
just this one.
Yes.
So maybe replot to add an additional plot using Slurm and to make comparison.
Yeah.
It will be rather good, and for you to compare the difference between Slurm launch and yes. Ron, are you going to make to do the 4th task? No? Okay, very well. Yes. No. Santiago wants.
I represent the graph from the homework 1. I send you the link in Telegram because I don't have a laptop. You didn't bring the laptop, sir?
No, I can. and open Telegram, yes? There is an error floating. I suppose it's some permission issues. Task 3 or task 1?
1. Wait, let me link. I send it. So the running time of H1. Speed up here, I don't know, it's a little strange because it like goes down a little and then goes up here. I don't know why.
And you have used Slurm, yes?
Yes. Yeah.
By the way, number of cores, no, if we consider MPI, so maybe it is more reasonable to number of processes, not processes. Number of processes, because when you do with pthreads, for example, or OpenMP, it should be written here number of threads, something like this. Okay, so let it be like this. Yes, the speed up is very strange because it no more than 2. It's not so good. No, but one question: why, for example, if we consider just 10 processes, so we are here 10 processes. And we are on the vertical line here. So the main difference in this case, the number of points, the number of segments. This is the main difference. All other things are the same. Your program the same, number of processes the same, and so on.
But it just has more points.
Yes. Why? When you use more points, the speed up is greater. Better.
Because to calculate the speed up, you have to calculate like the serial code, the time that took the serial code divided by the time of it took for any number of processes. Okay, so if the difference is greater, so the speed up is greater. So if 1 second. I think that because when we have more number of points, and the serial code, can I write like everyone? So we have the serial code time, suppose that it's 2, and we have the parallel time of, I don't know, 10 processors. So if this value gets smaller, the serial time will get larger. In this case, you told me 10 points, so the serial code time will be some number, but this one, it will get very large number with more points, right? So the serial time will get...
The time will be more.
Yes.
So some small hint. In the ideal case, these speedup graphs should be coincide with each other, and they should lie on the bisection. In the ideal case.
Okay.
So all systems are not ideal. They're not ideality in the network.
Why?
Because it takes some time.
Okay.
To send something.
Okay.
So how this non-ideality of network influences on the speedup? This is the question, by the way.
You mean like this difference of time, like the bisection is because of the senders and receivers? Can be.
No, I mean, any sending signals or any sending variables through network will take some time to do this. And this time somehow influences on the speed up.
With more points, we do more sense.
And we can see that if we take more points, the speed up is better. So the question is, why is it so? Okay, so
the only thing I can think about is like the difference between, for example, with 6 cores and 12 cores, for example, the difference between.
No. We consider just one number of processes. Yeah. We are on the 10 processes, for example, and we go on the vertical line.
Because we are always divided by the same time.
Yes.
So it will always be the same speed up.
Why? We divided our array into the same parts every time. 10 processes, so that means will you take you this number or this on this? In every case, you will divide the array on the same number of parts because there is the same number of processes. What is the difference between these cases? Okay, one question. How many things or how many tasks you wanted to present me?
I wanted to present the second homework, but I couldn't. I just could do the graph that I already presented you, but if you want, I can present you again with the. You remember that Folio sent us the parameters of the second homework just to graph it? Yeah, I graphed that. You told me that that is correct, but the code wasn't correct for 11 points because the precision was, in my case, 2 digits, but it has to be 3. I couldn't make it. That's all. I just want to present like this.
So, so in general, you wanted to present just these graphs, and that's all.
Yes, for today.
For today. Okay, so you can think about my question on your place, because I can at the same time I can.
So this is the question. Yes, processor and the speed up.
It doesn't matter. 10, for example, 10.
Okay.
So why the more points you take, the better speed up is.
Okay.
Sir.
Yes.
Okay, so I checked your message and I commented the OMP set number of threads, but I still cannot run Slurm correctly. Can I share my screen and show you?
Yes, of course.
Okay, 1 second.
Я могу видеть вот здесь вот, сейчас у меня только сообщение, а он показывает экран. Сейчас я вижу вот такое. Да. Ну, нет. Вы видите то, что он показывает? А я нет. Вот. Yes, now I can see your screen.
Okay. So here is my Slurm script. I have 4 threads in one node. And here,
please. You want to launch OpenMP program? Yes.
Yes.
Why do you use MPI exec MPI exec here in this Slurm?
I'm not sure.
Because MPI exec means you want to launch MPI, as it was in the name, as it is in the name.
Okay.
By the way. Okay, and if you write down the name of the node, node 22. Let's check, is this node idle or not? So you can print yes and 4, and you can see that node 22 is idle, okay, and okay. It seems it is free. Yes, it's idle and free.
I checked it before. Yeah.
Okay, very nice. And we can see that there are only 16 cores. Okay, let it be. So you want to launch your program using 4 threads. Okay, CPU per task equal to 4. Okay, that's nice.
Okay, so let me try. I submit it.
And let's open your program. Do you set the number of threads inside your program or not? Yes, but where the function was? Where was the function? On which line? I suppose that if you define num threads, that means yes, on page set num threads. Okay. So yes, you can launch, I suppose. Compile.
Like it's working now. I guess let me change the script one more time. This should work. Okay, let me. Okay, yes, it's working now. Thank you. I will continue.
Okay, which task do you want to present me today?
It's the 4th one. I only have grabbed this locally because I didn't. I couldn't connect to the computer. Now I'm going to try to get the point, the time to graphics. But I will.
So just task number 4, yes?
Task number 4 and the graph for task number 3. Because I see the last time that not using.
Okay, I see. Very nice. Monica, what about you?
I'm doing the graph and also I want to show you number 1 and number 2 and number 3. And what is the number 4? I have time.
No, you have time.
Just one more question, sir, very quickly. So you see here on my code, let me show you. Where is it? Okay, here, originally on this line right here, instead of having OMP, get number of threads, I had the number of threads that I had defined in here on the top part. But since I'm not using this line anymore, I'm guessing that every time that I run the code, I just get 1 here as a result, right?
And what is the question?
The question is that is there a way to before the parallel part, is there a way to get the number of threads that are going to get used? Because I know that if I put this line here, I will only get the amount of threads that are being used at this moment.
Yes. Because onP get not threads returns you the number of threads which are exist right now.
Yes.
So that's why when you outside the parallel section, there is just one main thread, master thread. And if you want to get the number of threads running right now, it will be just the only one master thread, and that's okay. Not the number of thread you have wanted somehow before in Slurm script and so on.
So my question would be, is there a way to get that number before the parallel part or not?
Just you can get this number just only in the parallel part only.
Okay.
Because when you are in the parallel part, in this part a lot of threads can exist, and you can get this number of threads inside parallel section because they are already running in this section.
Okay, I understand. Okay, thank you, sir.
Sir, I think the Slurm is not working now. Slurm is not working now, I think. Yeah, but now it's not working.
I can check right now. And
actually, when I run my program through NPRL, it's working. But when I use Slurm, it's not working. The output shows nothing. And when I get SQ, it shows nothing.
Let's try, because right now Gabriel has launched.
Even I launched.
And Critical launched and Slurm. Maybe you check check the name of the node where you launched. Maybe this node is drawn, or you should take the idle node, the free node.
So the way you told me to change in the batch file. Now I got it like this.
But it is a little bit better, I suppose.
A little bit better, but why is it?
I don't know.
Constant.
Don't know. No.
These are the values that I get. I just wrote it for reference.
Okay, so you, how have you computed the speed up? Firstly.
Serial upon all parallel. Upon parallel.
And how many points do you use when you consider this task?
16 at most.
No, this is the number of threads, but I have asked about how.
Dx, 10 raised to 6.
10 times
6. 10 raised to 6, yeah.
6, and this is the third. Fourth?
Yeah.
Fourth, I mean, fourth, yes?
Yeah, 4 upon 1 plus x squared.
Maybe, what will be if you will use not 1 million points, but for example 10 million points to make these times greater? I suppose that when you consider more complex task, it will give you better results in terms of speed up.
So I should increase the number of points.
If you want to show to finish only this task, only this fourth task, let's try to use not 1 million, but for example, 100 million or even 1 billion points, and use just several number of threads. I mean 2, 1, 2, 4, 8, and 12, for example, to make it faster. Firstly, change the number of points inside your program.
Okay, right there. How much? 10 to the 8?
Let it be 9 here. One minute, please. One minute. By the way, your approach to use OMP is not correct, by the way. I now can see this. Because you try to divide your interval into parts,
Yes.
Each part for one thread.
Yes.
But in OMP approach, and you just divide as it was in MPI, as it was in, I didn't remember, have you done the task number 3?
Yes.
Yes, let's see. You haven't, yes?
I have. I've showed you the task number 3 last time.
But
I've showed you the task, but you asked me the question about semaphore. You told me to answer on Telegram. I did.
Okay, I see. Yes, I see that. I saw that.
And
Okay, so you want to do the same way as it was in pthreads, but in OpenMP there should be another way, another approach to parallelize. It is rather simple, by the way, simpler when it was in pthreads. So the approach is to use OMP4 directive.
okay.
OMP4 directive, that means it will parallelize OM for loop by itself.
But can I just take that? Just a minute. But if I do that, if I use OMP for
Pragma OMP4.
yeah, Pragma OMP4, then whatever will be written in my this in my loop, this will be divided. For example, I have 4 threads. This task will be divided into 4 threads, right?
Yes.
But here I want one thread to complete the whole task.
Why?
Okay. For example, I have graphed something like this, and I have to calculate the area. I have many dx's, for example. This much is saved by thread 1, for example. Now I want it to calculate the area for each of them, and then sum it, right? So I'm doing it using the for loop. But if I use Pragma, I will have, I'm not able to explain it. There will be many threads doing this task.
No. So consider the whole task.
Okay.
As it, firstly, you can create serial code and let you calculate the area under this line and under the function using just serial code. If every step inside for loop statement are independent to each other, and they should be so, they should be independent. So you can divide your for loop into parts. The number of these parts are equals to the number of threads, I mean. And this can be done using OMP, Pragma OMP4. These steps inside for loop will be automatically divided into threads.
Okay.
If these steps are independent, and in our task these steps are independent. So you without consideration like x equals to times my ID times something, without so I mean every time in your for loop, yeah, in your for loop there is some x0. What does it mean x0? X0
dividing the interval. Yeah.
Yes, intervals, and every thread starts with x
Yes.
with x0 with its own x0 it starts, and so on, and it starts to calculate something.
Yes.
But for example, in the serial code, you say just what do you say? Just 4, yes, and there is an integral, yes.
Yes.
It doesn't matter how many threads will be here. You can just say here will be from I to I minus n, some n.
Okay.
And you can print x equals to I times delta x. It doesn't matter what is the number of one thread. Will it be 0 or 10? It just see that it should work with this value.
Okay.
And these steps inside for loop are independent, so it can calculate x. I mean some point here.
Okay.
And it knows about delta x, and it can start. Okay, another way. So how can every thread get the x0 with Pragma OMP4? Yes, Pragma OMP4. So let it be from 0 to I equals to 10, and it will be just 2 threads. These steps will be divided, okay, let it be 1, like this, to 5, and I from 6 to 10. Every thread see the first I times delta x, and this is the first I will correspond to the first x, and it will be x0 in your consideration. If thread number 2 goes here and it see the initial I 6 times delta x, and it will be x0, yes, this point in your consideration, and it starts to calculate each part of integral starting from this point to the very end.
Oh, so it happens automatically.
Yes. So try to change your approach and in terms of OpenMP.
Okay.
And maybe after this,
It's better.
yes, maybe.
Okay.
But you should use OpenMP approach to parallelize or for loop.
Okay.
Yeah, use the critical sections then?
So it's rather simple.
Yeah, fairly. Suppose we run it on 3 threads.
The main difference between critical section and atomic operation is that atomic operation is just for one operation, for example, plus or multiply. And critical section can contain inside it a lot of operations, a lot of lines and so on.
But I like to use reduction more.
Okay.
I like reduction more. Yeah. So
it's up to you.
And now I want to try to finish the graphs for homework number 2.
And what about graphs for task 4 with Slurm?
Oh, should I do that, sir?
As I expected that. No. 1 minute. Yes, this is on your laptop.
Yes, sir. But not using Slurm anymore. I can do them, sir, if needed.
Didn't we discuss this?
No.
I suppose.
You told me to do the critical section part, but I can do the Slurm part right now. If it works, I'll...
Okay, it doesn't matter. And what do you want to show me? Graphs for task 2?
No. So I want to do them now, sir. So this is the graphs for task number 4.
Okay, so, okay, let it be. You have graphs for task number 4. Let's do graphs for task number 2, yes, because you do not have...
Yes, sir.
Okay.
Thank you, sir. Thank you.
Okay.
I is like total number of times I want to do it, right? So,
Yes.
So in our case, this.
Ashish, and what about graphs for the first task?
Graph consists of 30% of the total marks.
Huh?
Graph is 30% of the marks.
No. As is.
Sir, I want to show you my graphs.
Okay.
So how many marks do you have?
This is for
1 minute.
task number.
Monica, 1 minute, please. Hmm?
No, I'm just asking how many marks do you have up to now? Did you calculate how many marks do you have?
I was doing right now.
What kind of table did you use? Can you just report that?
So, Monica, I'm listening to you.
Okay, sir. This is the graph for task number 3. No, number 2.
For task number what?
3,000 points. This one is for 10,000 points, and this one for
Which task? I didn't
number
catch.
2.
Huh?
Task number 2.
Number 2.
Yeah, I only have this part left. Do you remember that you checked it and my graphs were wrong? So this is and I wanted to show you for task number 1.
No. Let's stay at the task number 2 because from my notes it should be not only graphs but a code also. So processors, that means processes, by the way.
Okay, sir.
And I wanted, of course, so it seems that it isn't efficiency but speed up.
Yes, sir.
No? And if you go down, for example, on this graph, speed up, okay, latent B, and here. So this is speed up for which number of segments?
50,000.
15,000. So
50.
I wanted you, by the way, to plot these graphs on the same coordinate plane to see the differences between them, firstly. Can you do this?
Yes, I will do it, sir. I did the same with the others, like separately too.
What is this?
This one is for task 1.
А вы можете взять погромче? Она тихо говорит, и как-то им плохо слышно, если честно. Okay, stop. What are you showing me right now?
This one is like, because I did it like this too, like in 3, not in 1. This one is for.
This is for number 1? No. Stay at number 2 firstly. We haven't finished the consideration of these graphs. I wanted you to plot these graphs on the same coordinate plane because I have some questions about these graphs. About graphs on the same coordinate plane.
Okay, sir. Give me some time.
Of course. If says if turn back to the task number 1, I can say that I see some strange behavior of your speed up. If this speed up, it should be for you very strange to make speed up like 10,000 or 1,000 and so on. Don't you find it very strange?
Actually, yes.
Спасибо.
I'm going to do this one again. And, well, I'm going to replot this. And,
yes, report.
Actually, I'm going to ask you a question about task number 3 too, because Like I did it on my computer and then the cluster wasn't working. So should I do this one, calculate this again?
I think yes, it's very strange.
Okay, so.
And by the way, I want to see the code of task number 2. Yes, 2. Graphs for number 3, and there are a lot of questions about task number 4, I suppose. Okay, let's see your graphs firstly. Santiago.
Sir,
Yes.
can I show you my step forward?
Yes.
All right. Should I start by running the code?
Of course, of course. Launch it.
For how many threads?
This is, and how many points do you use?
For the fourth task, I use 1,000,000.
Just 1,000,000?
Better.
Okay, no, let it be three threads.
Okay. Hold on. Right. I don't know why now it's not taking me the three threads, but it was working just a minute ago.
Let's see the result. Let it be 4 threads, it doesn't matter. What is the result? What is the answer? Let's see the answer.
Okay. Run it again. Sure.
Uh-huh.
There it is.
I see. And what is the exact answer? How do you think?
It should be pi also. I mean, because we take the 4th out of the integral and we get pi divided by 4. And by multiplying it by 4, we get pi. Because this is an arctangle.
Yes, you're right. Okay, let's see your graphs.
Okay, so that's the interesting part, because before the cluster worked, I run it locally on my computer up to 4 threads, and I got this graph, which they are not completely good, but okay, this is what I got. But now that the cluster is working, I get this bad results, should I say, because I don't know why I'm getting these results. Maybe I can show you my code.
Yes, because first of all, the graphs of reduction and critical section should be almost the same. They should almost be coincide, I mean. And if you look at this graph, also, even if you run it on your local machine, the graphs should be very well coincide with bisection up to 4 threads. But we can see something wrong with critical section, and besides that, do you have, okay, your laptop has 2 or 4 course, physical course, I mean? Do you know?
I don't really know. I don't remember, to be honest. I'm not sure.
Okay, doesn't matter, but okay, let's see your code, because I don't know, maybe something wrong. So this is OMP, yes, OMP. Okay, go down, main.
Okay, this is the parallel part. Here I have my critical section. And basically that is it.
Stop, one minute, please. On P, and let's go to the function trapezoidal, please. No, there is no any parallelization, by the way. I mean, no. You should use the OpenMP approach to parallelize your program, because now you have not done this. You have not used the OpenMP approach at all, by the way.
What do you mean? I mean, I here have my parallel section in.
You just what you do? You just divide your interval under consideration into parts equals to number of threads. That's all. You divide it and say to every thread, calculate this part of interval and so on. No, this is not OpenMP approach. The OpenMP approach is to automatically divide the for loop, for example.
By using OpenMP.
Yes. This is approach for POSIX threads, for example. Now try to change this to use directive OMP4 to parallelize for loop. This is not good. No, this is a mistake in this consideration. If you use OpenMP, use OpenMP.
Okay.
And maybe when you will use OpenMP statements, the speed-up graphs maybe be better.
Okay, I'll try.
Pragma on P4, total points.
I did not check the answer. Just a minute. I did not check if the answer is right.
Okay, so now graph.
Yeah, I drew the graph.
It's getting better. It's getting better. But not ideal. Okay, let it be like this. And what about the second approach? I mean, reduction. Yes. If you do not want, I just can give you a little bit less mark if you want.
I already have very less. How much do I have?
Let's see. Can you please show the graphs, because I could not open graphs on my laptop. I don't know why. On P4 and Gabriel also on P4.
Oh, the loan was not working at that time. This loan was not working, so it was just a door.
And you have done without pthread exit, as I remember, yes? Okay, so now we have which one? Number 3. Without pthread exit and on the client machine only?
On the
or on the local?
No, not just on the local. How do you call it? How do you call it?
Remote?
Yeah.
Remote client machine. Remote machine and client node.
Yeah.
Client node, cloud machine. Okay, I see. 3, number 3. Okay, let it be. So you have to show me just 2. You have not want to show me task number 2.
Yes.
Okay, like this. We'll see. On P4 and graphs and without reduction. Graphs. No. Okay, let it be 7. Firstly. We'll see. Here 7, and here, for example, let it be 8. 3.9.
And if I do reduction, how much?
Okay, if you, for example, if it be here 9, but okay, if reduction graphs, okay, let it be 4 or 9. Okay, 9. Let it be 9. We'll see. It will be 4.
So no way 5.
If it will be 9 here, it will be. But 9 is. It's the maximum. I mean, just imagine what will be. So in any case, I suppose yes, 3. I mean. I want 4, and even if reduction, let it be 9, 4 without, but also I want, by frankly speaking, let it be 8, if without reduction 7 point. So anyway, yes, I suppose it will be 4.
Okay, this is like the last time we can show anything. So what do if I try something today? Maybe no.
No, by the way, the final, I mean, the final day I should put your marks is Wednesday.
So before that, if I do something of the homework too, can I still have chance to get 5 or no?
For example, the maximum value will be 5 here. Yes, you can, but you can maybe. But this is the maximum mark here. Maximum mark because it will be divided by 2.
Yes.
and this is maximum but
So by maximum you mean graph? The whole
graph
correct answer.
yes, of course. And this is maximum, even maximum 10/2. But because of even if some man some person do this almost good, it will not maximum. I give him over 9, mark 9 maximum approximately.
Okay, so not possible.
Yes, almost not possible.
Okay.
You can try, of course, but
So till Wednesday.
yes, but till Wednesday, but I will be busy these days because so and of course I wanted to
Like this.
to listen to you remotely somehow.
Okay.
So it will be just one time when I can, maybe on Wednesday, maybe. So it will be hard. But by the way, if I look at your attendance, yes, it's not so good, by the way.
Yeah, where is it? Okay, first. Okay, understand.
So now I put here. Yes?
Yeah.
Okay, the final. Okay. Run. Графики сложно построить. Ron, for example, is what I can say about you. For example, you see that for task number 1 there were mistakes in code. Fixed. If you have fixed, and you can show me. And what about graphs?
Graphs are still bad, like the previous but graphs are bad.
So there are also questions about task number 2. You can see. I suppose that there was something bad with the answer, and about graphs also.
Graphs I showed it to you, sir. Graphs I fixed, but the answer is still the same.
So when you want to show me graphs and fixed mistakes in the task number 1? When?
I can show you that one.
Okay, Santiago.
Task number 3 graphs.
One minute. Do not forget about Santiago. And that's all. One minute. This is. Okay, so what do you want to show me?
You just asked me to make the graph using Slurm.
This is for task number 3.
Yes.
Okay. Do you see the difference?
Yeah.
Dramatically difference,
Yes.
by the way.
Yes, sir.
Okay, so
If you remove this, and this is just the type machine, and then this is with the.
okay, so number 3 now it has good answer, and you have used
Slurm.
just critical section, yes, and slograms. Okay, let it be. Okay, 9. You can say.
I'll show you the first one.
Santiago, are you going to show task number 4? No?
There is no time, yes, today.
And there was question about task number 2 about graphs.
Which one?
I suppose there are no any graphs for task number 2.
Yes, presented.
Presented?
Yeah. I can show you again.
Task number 2.
The graph, yes.
Yes, please remind me.
It's in the Telegram. I send you the link.
Santiago, where are you? Here. This T1, T3.
Oh, okay.
There are no. I just didn't remember. Gabriel. Answer plot. No graphs. Let it be. A, for example. So 8 for 3 and P 5. What else? Answer plot. Gabriel.
Yes.
Last class, which task have you showed me last class?
The third one.
Task number 3, yes?
Yes, yes.
Okay. Because there are questions about task number 2, there are bad answer, as I remember, and there are no any plot, graphs concerning task.
There were plots for task number 2. Things that they were wrong.
Yes, something like that. And it was bad answer, as I remember, and there are no graphs for task number 1?
There were graphs, but they were incorrect also.
By the way, these graphs are rather essential because, as I'm repeating now, of course, but you should do two goals. I mean, 2 goals when in your parallel programs. First goal is to get correct result, correct answer, and the second goal is to get correct, or I mean good speed up, because parallel program is not only for getting correct answer but also for getting good speed up. If there is no any speed up, that means the parallel program is bad, because this is our goal, to get good speed up. Okay, so for let it be 7 for task number 1, because plot was warped.
Okay.
Let it be 7, and bad answer for task number 2, and warped plots, I don't know. I clearly didn't remember, so maybe 6 or 5. No, let it be 6. With bad answer. We'll see now. The preliminary mark is 6.4. So it's 6 if round.
Okay, I will try to finish.
And this is without Gabriel, and I just put 5 for 4th task approximately, because there are also graphs wired and without OMP approach.
Yeah.
Preliminary, of course.
Okay, thank you.
I have the link this in Telegram.
Do you have answer on this question?
I'm watching the lecture in which you explain that.
The same thing. Well, yes, on the same Cartesian plane, and you can see the same program, all the same number of processes, like this 10, for example. And when you go up on the vertical, you can see that the speed up gets better.
Just changing the number of points, right?
Yes. So this is the graph for the task number 2. Yeah, так, where are you? Santiago. Plot. Now let it be number 2. Graphs very good, by the way. No questions. So 10, and without task number 4, yes, right now. So it will be 9. Santiago, it is 7.45 right now, preliminary. Let's see how many times you are in. 3, 4, 5, 6, 7, 8, 9, 10, 11.
So can I give him some of my attendance?
Don't know. No, I suppose no.
He did 0.5. Also, if he gets 0.5 more, he gets an 8. Such a small margin. Yeah.
Okay, you wanted to show me something.
Yes, sir. The heat, the second homework, speed up graph.
Mm-hmm.
So firstly, I wanted to see the, how can I say, the graph itself, the time compared to processes. Sorry, so I was just rushing fast. So I see that there is some type of speed up, and so it does for 10,000 points and for 50,000 points. And the speed up itself looks like this.
Rather well, especially for 50 key points. And do you know about why these graphs are so different from each other?
I just didn't remember the question correctly.
This is the question for Santiago also, by the way. It's time.
I have to run as well. I'm sorry, next semester I won't be in for classes.
Who?
So next semester we have also parallel programming.
I don't know exactly. I suppose that it will be about big data approaches.
But next semester I won't be in classes.
Why?
I'm transferring to another university, so unfortunately, yes, sir.
But why? Unfortunately, because I'm not going to to be here next semester.
So I thought you were teaching us. But why, sir?
Because I'm how to say, not a specialist in this area and like this, so it will be. And which university?
I'm going to United States, Brandeis in Massachusetts.
Very
Close
well.
to my family, so.
Very well.
Thank you, sir.
So let it be 9 for 9. So now in score for tasks and +1 for visits, so no questions at all.
Thank you very much. It was a very fun semester.
Thank you. And
I really enjoyed parallel. Actually, I want to go more deep into the subject. Hopefully, the other universities they can tell me. But especially when we talked about the CPUs and the graphics card and how you can, I don't know, the more cores and the more things, the more threads we can actually do. I'm really interested in that subject. So.
Very nice.
Thank you very much, sir.
So good luck
Thank you, sir.
in your new university.
Thank you, sir.
First program, first I was getting a wrong answer. Now serial sum and parallel sum are the same. And we have to
But let's try to use one.
it crashed again.
No, it's frozen, I suppose. And let's try to use just 10 points. I mean 10 numbers, 10. This is.
It will take time, so I think it can take Ashish because it's logged out.
And this, the graph for the second task.
One, yes, This is, you asked me for the graph for the second task. The answer for the second task is similar to the solution of template which you sent, but it's not so close. That was the problem. And it's still the same way, so it's still the same way. I didn't.
No, I suppose. So, I didn't remember the solution, but I have marked in my notes that there is something wrong with the answer.
Okay, yes.
If, by the way, the numerical answer should be a little bit different from the exact
Solution, okay.
yes,
okay.
exact. So it's okay, but something wrong.
No, I can run it again and show it to you. But this is the graph. The graph.
Yes, I see. So graph is okay now with Ron. You are here. number 2 plus graphs. Okay.
So should I change n to 10? You asked me.
Yes, 10. А ничего, что мы немножко задерживаемся? А, они здесь? And 3 processes. It seems good. And what about graphs?
Graphs are still looking like this. I don't know why, but this is the original one.
Yes, mistakes in the code. Ron was mistakes. Can you show the code, please? About code of first one.
Yes, sir. The main problem, the mistake was serial and parallel were not similar, and then now it's similar.
Okay, now it looks good. And answer task number 2, please. Can you launch it?
Yes, sir, I will launch it now to look at the comments.
Task 2 graph.
Task 2?
Yeah, task 2 now.
How many points do you use here?
50,000.
50,000, and that's all. And by the way, using 50,000, the speed up should be much better, by the way. And you haven't used 10,000 and 2,000, yes?
And I have done the second approach for reduction and by shared.
Which approach?
I have done the 4th task by normal shared critical section approach also. Yeah. And by reduction also.
And what is the purpose of critical section?
So the same to modify the global variable, shared variable. If you want to do any operations.
Ashish. So, number 2 graph, just one graph, only code. And can you launch task number 2?
Yeah, I showed you already.
No, I mean number 2.
Yeah. Task.
Okay, I suppose we can arrange one remote meeting once more, just only one, because I think no, it's a lot of numbers.
No, it's not. Yeah.
I want to see just in 11 points.
I was calculating.
So, number 2 now. It is correct answer, yes? But graphs, okay, let it be score for tasks. Seven or 8.
8, I think.
Okay, let it be 7 or 8, but right now let it be 7, just to see what will be. what will else? So number 1, plot bet. Let it be also 7. 7. Let it be 7. What else? Number 3, run ans, plot code, and now you number 3 without graphs, yes?
Yeah,
without graphs, but good answer.
Yeah.
So also 7 without graphs. And what about number 4?
Yeah, correct answer, no.
Also 7. Let it be 7. Somehow 8 because of your attendance.
And what if I did all the graphs?
No, it will be better, I suppose.
Okay, I have time. I can make it. I can improve my marks.
You can improve, I suppose. A little bit. So we have finished our class.